Welcome back to the Land Tamer stream. We're back to doing our multicast labs and digging in. We're gonna go back to sort of where we left off with the PIM Assert. I wasn't happy with how that ended, so I really want to go back to that and take a look. We're gonna do some more packet captures, and we're gonna understand this thing because I think it's very important that we understand in terms of traffic flow how this DR selection works and impacts the traffic flow and where it can go wrong, right? So it seems like a pretty important lab to understand the PIM Assert. And I don't want to just kind of gloss over it because I think that's going to make it more difficult going forward. So I had time during lunch to read up on the PIM Assert and how it impacts traffic, and I want to take a look at that now. I think I understand it better now, but I want to make sure. So I left everything running. So the PIM Assert lab is up and running, all the configurations. This, by the way, of course, had to change my desktop wallpaper. That's just me. I get bored pretty quickly, but this is in the Port Canaveral Welcome Center. It's a really cool place. You can actually, if you go to the top here, they let you up on the top deck. You can look out and see the you can see Missile Row and the launch pads at Kennedy Space Center from up here. They have the Falcon Heavy is launching February 6th, I think, is scheduled launch. Man, I'm so looking forward to that. I don't know if I'll be able to see it, but it's Tuesday night or Tuesday. But, you know, that's a big rocket. Anyway, if you were to go here now, which we're going here, I think probably next weekend, we'll be able to see the Falcon Heavy on Launchpad. I think it's on LC39A, I believe. But anyway, cool stuff. Getting back to the lab, though. I'm liking using this dock down here more. But I'm going to pull up the requirements are the same, the configs. We're going to pull up our map here. We're going to take a look at that. We're going to pull up, what else? Oh, the chat. Let me see. Where's the chat window? I just had that down there. I think it's here. Yeah, Twitch chat. It says Twitch, but we got the chat window. And what else? I think that's it. So, okay. Oh, the terminals. Still fighting a sore throat here for some reason. All right. So the issue if I understand this correct, I want to walk through the PIM Assert lab from the INE workbook and how this is supposed to work. And what I want to do is I want to make sure that that is indeed the way it is working in this lab. And we're going to verify everything, every change before and after. We're going to do packet captures and make sure that we understand how this PIM Assert works. So let's go through these requirements again. Standard disclaimer, this lab I'm doing is not one I designed. It is from the INE workbook, which I do not show on the screen. If you want to do this yourself, definitely check it. The link below. You can purchase the workbook yourself and go through these labs. You can see all the material that's in there. I'm paraphrasing some of the requirements, but that's nothing like what the material that's in there, the configuration, the explanation, the screenshots. It's awesome. Anyway, PIM Assert. So the requirements here are that we're in dense mode, router 6 through 10. And what that means is this path. It's not just saying on the Ethernet path between router 6 and router 10. And we want tunnel 10 to also be in dense mode between router 1 and router 5. And we want to ensure that router 1 is always elected via PIM to flood traffic to the VLAN 146 segment, not router 4, just router 1. We want to use one static multicast route to fix the underlying RPF issues. What are those issues? I didn't see them before. I think we'll see them now and hopefully understand them. Then join router 6's loop back to group 239666 and ensure router 10 can send packets to it. So let's back this out a little bit. We're going to go back to router 6. We're going to back out the config to about here. Actually, we're going to back it up to here. Okay. So let's go to router 6. show run section, actually show run interface, just 0, 1, actually loop back, I think. Yeah, so it's on the loop back. And we're going to remove this. Okay. And let's check the static route on router 1, see if we still have a static route there. May have already removed it. Maybe mount is not one. Taking this a little time, maybe. Did it go to sleep here? I'm going to shut down some. Are we doing any traffic captures? No. There's some switches running that we don't need. There's some routers running that we don't need. We don't need right now to be running router 9 or router 7. And we don't need router 2. We don't need switch 1, 2, 3, 4. So just for a sense of economy, let's stop those nodes. Okay, there is an MRoute running, so we're going to take that out. Okay. Tunnel 10, yeah, that should still be... All right, so we're back to... We are right here. Well, let me check. Did we leave anything else running on 146? No. Okay, good. So here's what I expect to see. I expect... This is saying that router 4 is running EIGRP. And OSPF. And that router 1 is only running OSPF, which is a bad design, it's saying, and admittedly, yes. It's saying the route to router 10 is going to go through router 3. And I'm not sure why that is. Route to 151, the IGP route. Okay, that's what the workbook says. Let me just verify that. In our scenario, router 1 and router 4 run different IGPs. In our case, under normal circumstances, router 4 would be the assert winner because of EIGRP 8090, then OSPF 8110. However, R1 needs a static route, MRoute, out its tunnel 10 to R5 to fix RPF issues. So are we saying we have RPF issues with router 4? Or is it saying on router 1? I think it's saying on router 1. Router 1 will receive multicast traffic 15108.10 on its tunnel 10 interface, but its IGP route to get to that source is via its GY113 interface. Okay, so we've got some screwy things going on with IGP, apparently. Let's look at that. That wasn't immediately obvious to me. So first of all, show IP protocols. And we do have OSPF 1, right? So routing for networks and area 0. All right. default is 110. I don't see a route for router 10. Show IP route 151.10. What is it? 108.10. Okay, it has two routes. One 151.15.5. Okay. This is where I think we've got a disconnect, guys. And this is why inaccuracies in these workbooks really upset me sometimes. All right. So the assertion here in the workbook is that we're going to have an RPF check problem because router 1's route, best route to 155.108.10, yeah, it even says it here. And I'm going to show you a brief little screenshot just to, back myself up here. Okay, so the workbook says, I'm just going to quote a small portion here. In our scenario, router 1 and 4 have different IGPs. R1 look at this. It says R1's IGP route to get to that source is via GI113 interface. What are they talking about? Why would it even want to go that way? Okay. So I guess what they wanted us to see here is an issue with routing, that it would for some reason want to route this way. R1 receiver multicast traffic from 151.108.10 on its tunnel 10 interface. But its IGP route to get to that source, yeah, that is so not true. I mean, our traffic in the end is going to go, our multicast flow is going to start at router 10. And I think what they're saying where we want it to go is this way. But that's the way it's going to go right now. There's not going to be any sort of RPF check failure. As a matter of fact, right now, router 4 should be the designated router on this shared segment. Actually, router 6, well, this is by group, for each group, right? For each star comma G. I think the star comma G would be, once we see traffic flow, the S comma G would come through router 4. Because let's look at router 5. So if we look at the RPF check for router 5, it should have, what is its IGP cost? Show IP route 150.1.6.6. It's through router 4. It's running EIGRP. So really, the premise for this whole lab is kind of blown. I mean, I don't think I can complete this lab successfully because, first of all, okay, here's what I did in the lab. Basically, the way this lab is built, it's always going to go this way. Now, what I did in the lab is I did an assert and forced router 1 to become the DR for this segment, which means this would do a prune and traffic would now want to come through router 1. And that would be fine. So let's see if that happens. Yeah, and that would be fine. There's no need to put a multicast route here, is what I'm getting at. Yeah, if it does go this way, the RPF check is going to work just fine. There's no need to do a multicast route. It's completely unnecessary unless all we have to do is a PIM Assert here. I don't see why they feel the need to do a multicast route. The premise is if that I do a PIM Assert, that I have an RPF check problem. Okay, so here's what we're going to do. We are going to, step one, we're going to break this down, guys. We're going to break down this lab and you know, chop it up, okay? First thing I want to see, here's what I want, objectives. I want to observe initial PIM DR election. In packet in PCAP. Okay. I want to observe initial PIM DR election at the console. Okay. My other objective is to test PIM Assert on router 1 and assess the impact. All right, this is the one that's going to be a little tricky. All right, so, and I think we did this before we had a problem. So if I do a PIM Assert on router 1, that means that he will prune on this interface. Now, does that mean he will send a prune this way? Okay, so what we want to do is observe PIM and IGMP messages from router 4 and observe impact at the console. And what we're going to do for the console, we're going to do debugs. All right, we're going to understand this thing, right? Because I think I did this and it did break the topology. And if it does, we're going to, if it does break it, we're going to see how we can fix it. Whether that's an IPM route or whatever the case may be, all right? So let's start off. For this first DR election, what I'm going to do is we know that there will be a DR election for, like right now, if I do show IPM route, there's a 2240140, right? Incoming interface null, outgoing, we've got 3 different interfaces. And I'm not sure, I don't really care too much about this one. Yeah, so I think what we do is we start a capture here. We turn on debugs on 1 and 4. And we add the IGMP join message here. Yeah, I think that's what we want to do. And then we want to observe the DR election process, right? We know 4 is going to win it, but we want to see how. So let's go to our environment here, and we're going to go to routers. We're going to select all. We're going to do a capture on router 4, and we're going to do a capture on router 1. And how do we do a capture on IGMP and PIM and ICMP? Let's figure that out too. We gotta get our you-know-what together here on this lab guide. I don't feel like we had it together. So now we gotta get it together, and we're gonna go deep. So let's go out to our Google Drive share. Link below, guys. A lot of good stuff out here that may or may not help you in your studies. We have a cheat sheet folder now and packet captures. And in here, now these have their own protocol numbers. IGMP and PIM have their own protocol numbers. I wonder if I could just do IP proto PIM and IP proto IGMP. Either way, let's insert. How do I grab this here? There we go. Insert row below. We're going to say PIM IP proto. It's just PIM. IP proto PIM. And IGMP. Insert row below. IGMP. IP proto IGMP. Okay. I wonder if some of these I can just do display filter as EIGRP. Here I'm trying to do IP proto equals. I'm probably making that too hard. We'll come back to that. All right, so we're going to test that out. And we've selected our routers. Have we selected our interfaces? We have not. We're going to select these two interfaces. And traffic capture. And we're going to do, we have to put a group name because we have two. So we're going to do PIM Assert R1, R4. And the PCAP filter is going to be PIM or IGMP or ICMP. See if that works. Hey, it worked. Awesome. Getting better at that. So, all right. So now we're going to add to router 6 an IPM. Uh-oh, what happened here? Oh, yeah, it went down because I took the routers down. Interface Jazz 0, 1, 146, IPI, GMP, join group. And in this case, we are doing what? 239.666. Okay, shoot, we need to do a debug. Debug PIM. And I want to do that at router 1 as well. Debug IP PIM, debug IP IGMP. Okay. We probably missed our window on the console, but that's okay. We can redo it again. So if I do now show, will we have any traffic yet? A join message was sent. A join message was sent. What impact does that have on? So report, right? A membership report, send v2 general query. Update exclude timer. Receive v2 report. Okay, there we go. Receive report. Receive group record mode 2 for 0 sources. Add update GI0 by 0. Okay. Show IP M route. Okay, so we have a star comma G here. And notice the timer 106.239. We have it from a connected neighbor. And all right, tunnel 10 forward stopped. Tunnel GI0146 forward dense. Okay. So our incoming interface is null. Outgoing interface is these two. Okay, let's look at router 4. Cancel report. Receive V2 report. Receive group record. Mode 2. So show IP en route. Interface null is the same. And we could here go out to potential interfaces. And router 1 has the same as well, right? Yeah, 0146. So basically all the interfaces that are speaking multicast. Okay. Good deal. So do we have a designated router with just star comma G? And how do we see who is a designated router? Let me see. I think it's here in the... Okay, I think we have to generate some traffic first. So let's do that. Let's go to router 10. MRT updated by 0. Okay. So now we're going to do a ping 239.666. I don't want to do too many pings. That will really... Okay, update to... All right, source is 151.108.10. Forward state by PIM SG join. Send V2 graft acknowledgement. Add 0 to forward by PIM graft. Okay. I think the graft is for the star comma G. All right, sending V2 assert. We win. Our metric is this. Our metric is 1/0. Why is that? Send V2 assert. We should lose the show run. Oh, no wonder. I thought I removed this. No IP en route. All right, now let's see what happens. Yeah, we lose. Our metric is 90/3328. So we do a prune. Okay. Prune from blah, blah, blah. Insert prune in the neighbor's queue. Okay, so we see a prune go this way, and we see a prune go this way. That makes sense. I would like to see those prune messages. And I don't think there will be another election. There's a timer for the election, right? Let's shut the interface down and bring it back up. Interface J01146, no IP dense mode. IP PIM. And we're going to put it back. All right, he should send an assert metric, but we lose because ours is 110/20. Okay. Very good. All right, so after all this, what we saw, let's look back at our Objectives. Observe the initial PIM DR election in PCAP in console. We saw it in the console. Now I want to see it in the... We'll get to see both, right? Let's see. Let's download this. I want to see those prune messages. I like to look at my prunes. I hit it twice. I think I did. The volume just in case. Sometimes I hear stuff here. Okay, so on router 4, we're going to see both sets of DR elections. All right. So let's observe what happens here. We've got our hellos, membership reports, until we see this. Okay. So this is where we configure the membership. And then at a certain point, all right, so this is dense mode. So we still don't have, we still have just a star comma G until we generate traffic. And once we generate some traffic, let's deselect this. Now we see an assert message from router 1. Okay, nice. Metric preference is 1. Metric is 0. Cool, we got our assert message right here. Nice. RP tree is false, right? Because it's dense. Okay. All right, we can close this. Oh, I closed my file. Come back. Come back. All right, now what I want to see is when we remove the multicast route, we should see another assert along the way. Oh, we should see a prune too. I want to see the prunes. Show me my prunes. Join prune from router 4. Yep, right away. We get an assert. He's like, okay, we lost. You win, we lose. So I send to my neighbor a prune, right? Now, what does that look like with a prune? So now router 1 has pruned it because we took the static mroute out. If I do show IP mroute, what does a prune look like? Okay, the S comma G is a P, pruned, right? I guess a prune is better than, when you think about the overall architecture, I don't know that it matters. I mean, I'm still showing the route. It's obviously an invalid route. I don't know how that works. If I do a show IPM route, how does that work? Group address is first. So it would be 239. An IP name, can I just do that? Yeah. But I can also do the source. Cool. All right, so it's still pruned, right? Okay. So that's what the P means. And we send one out the other interface too to router 5. So router 5 at that point should only have one path. And right now it should be router 4. Show IP mroute. Yeah, notice this is stopped. So stop means is I'm not going to send it out that interface right now. I will send it out tunnel 0, tunnel 10. Okay. Now, this is interesting. outgoing interface. Incoming is this way, and that never works. So it sends it out tunnel 10. Now wait a second. Are we sending packets? No, not anymore. Okay, we'll come back to that. So we see our prune messages. That's what we expect. Router 6 sends a prune for what? Oh, this is a join, right. Hey, I'm over here. That's just the periodic join, okay. Okay, so I think I got it. So we observed it in the packet capture, and we observed it here. Test PIM assert on router 1 and assess the impact. Observe PIM IGMP messages from router 4. We've already seen these. So what happens is if we do an assert, let's think about this. So we've got that figured out. Okay, so let's go back to our drawing here, and let's think about if I do an assert. So now, when I do an assert, the prune will go this way and this way for router 4. So our path should be router 5, router 1 to router 6. All right, is that going to cause a problem with the RPF check? RPF check problem. Let's think about it. So router 10 sends traffic, or we do the assert. Now the incoming interface should be tunnel 0, and the outgoing interface should be GI01146. On router 5, the incoming interface should be actually goes this way, guys. It should go this way. Incoming interface should be GI0158. Outgoing should be tunnel 0. And here, right? So the part I'm curious about is router 5 is going to have several routes going back to router 1. Is that RPF check going to pass? It should. Yeah, it should go this way. Because it'll say the RPF neighbor will be the tunnel interface, 155.1.15.1, I believe. And then when it gets here, the incoming interface will be tunnel 0, outgoing will be this, and the RPF check from 6 to 1 should pass. So I don't see what the problem is if we prefer router 1 over router 4. I really don't. So let's do that. Let's go to router 1, and we're going to assert on interface GI01146. It is IP PIM DR priority is 10. Changing DR from 6 to 1 for this system. DR change from neighbors 6 to 1 on interface GI01146. Building graph message. No entries. Building graph message. No entries. Okay. So that's how the process works. Changing DR from 6 to 1. We would expect that naturally 6 is a winner unless it becomes the source, right? Changing DR from 6 to 1. Okay. So now let's do, we have IGMP messages being sent out router 6. So we should have a star, comma, 239.666. IP M route 239.666. And we do. Incoming interface null. Outgoing J0146 stopped, and it stopped. Okay. Yeah, incoming interface. Right, because all we've had is IGMP. All right, now let's send some traffic and see what the routing tables look like. See, we have no problem getting there. Join list. There we go. Receive v2 join from not to us. Send join prune to the tunnel. Build join prune for packet. Adding, yes. Adding v2 prune. Sending v2 join prune to receive join prune. I wish it would tell us which one. But let's look at the routing table. Show IPM route. Incoming interface tunnel 0, RPF check passes. Outgoing interface list, J0146, prune dense. This is PT, pruned. There are a lot of codes here. SPT bit set. P is pruned. Why would that be pruned? Let's continue sending traffic. This is PT. Okay, let's look at router 4. Interesting. So it is still taking... It's still going through router 4, I believe. A, it says assert, or candidate for... Yeah, I don't know what that is. So on router 4... Okay, T, yeah. Sorry. Looking at the wrong router here. So it's still going through router 4. So how do we know who the DR is? Show IP PIM neighbors. Show IP... Yeah, how do we see the DR? Interface, GI01146. DR priority is 10. Dense mode. Neighbor count 2. Show IP... Yeah, I'm a little confused. Send v2 assert, we win our metric. Okay, so this assert method apparently is not working. Because it's definitely taken the path through router 4. All right, what if I... Maybe it's like HSRP, where it's not... if you don't do, if you don't take over, if you don't preempt, maybe that doesn't work. That's what it is. See, I think I'm doing an assertion and I'm not. Interface GI 0, 1, 146. Let's make it really high. Preference given the larger value, right. Maybe that is not for all groups. Maybe that is only for star Kamaji? I don't know. Let's do this. Let's take PIM off. No IP PIM dense. And let's do it on router 4 as well. No IP PIM dense. And we'll do IP PIM dense. And IP PIM dense. Okay, I saw a packet here. DR changed to 1. Check DR after interface 46 came up. Changing DR from 0 to 146.1. This system. Let's see what it did on router 4. Changing DR from 6 to 1. Okay. Okay, so now router 1 is the DR. So let's see where traffic goes. And we should be able to tell by looking at the routes. Join prune. Show IP mroute. Prune. It's in prune mode. So interesting. That's the issue I was seeing before. This still, no matter what you set for this show run interface GI 0, 1, 146, no matter what you set for the PIM DR priority, for S comma G's, the IGP metric still wins. That's the only thing I can conclude. Let's take a look here at our documentation. This is something I came up with, you know, change the okay, IP multicast PIM, configuration guide, configure basic let's go to the command reference actually. So command reference and IP multicast and IP PIM DR priority will be here, I think. Did I select the right? All right, what? I've done that a couple of times. Okay, that's my fault. IP PIM DR priority. To set the priority which I selected as a dignity, use it in interface configuration mode. When a DR is a candidate for election, the following conditions apply. The router with the highest priority value configured the interface will be elected as a DR. If this DR, blah, blah, blah. If router's not, yeah, exactly. So apparently this is garbage. because that is not what happened for the S, G. So it looks to me like the only thing really influencing the PIM Assert procedure. Yeah, okay. All right. So the only way I can influence, the only way, RPF check, there's no RPF check problem. So we have not yet successfully done a PIM Assert. The only way to do that really is to add the M route. So IP, let's do IP M route. Wait, I think it says in here we could use the distance argument in the M route. Okay. IPM route, and this is the source address 151.108.10. And the mask is 5.205.205.205, and we want to use the interface, tunnel 0. And we could change the administrative distance for the route to still make it go through router 4, but if we do that, next top IP address required for multi-access media. Interesting. So I'm telling you guys, this is what is in the workbook. This is what's in the workbook. So again, we have some big disparities on this lab, Ione. If you're watching, which I know you're not, need to fix this lab, PIM Assert. 151.15.5. Actually might be show IP interface brief. That may be wrong. No, that's right. So now if we do show IP, are we generating traffic? No. We do show IP M route 239.666. This says PT still. Prune. Incoming interface, tunnel 10, RPF neighbor, M route, PT. Is that wrong? Receive group record, show IP M route. Okay, there we go. We're getting a little bit, some changes now. Now it's PT over here. And okay, now it's T over here. So it updated. Took it a minute. Okay, and now we might have a problem. So now my configuration is just like now it's just like the workbook, and it doesn't work. Okay. Let's find out why. All right, it says it stopped. Assert winner. Show IP RPF. 151.15.5. Directly connected. Multicast connected, doing distance for lookups across tables, RPF topology, yeah. Oh, the source, we want to do 5108.10. RP interface 10, RPF neighbor, yes. Right. Okay. How about router 6? What's going on? Why can he not? Why did this break things? Show IPM route. Incoming interface, RPF neighbor. What does the star mean? This should be right. Oh, does that mean it fails? I don't see, it's got a star here, but show IP RPF directly connected. What does the star mean? And why is it pruning? Why are you pruning? So this looks good. Incoming interface, RPF neighbor. Okay, so let's work our way backwards. I still don't know what the star means. This says interface directly connected, RPF route mask, doing distance per lookups across tables. Yes, this all looks good. So going back to router 1. Okay, this says T now. That's good. Is this working? No, it's still not working. So it says T, outgoing, that's correct. So stopped, A, assert winner, M route. This all looks good. All right, let's go to router 5 then. Show IP M route. Okay, T, that's good. RPF neighbor. Outgoing is tunnel and... Oh, it's trying to send here. So we might have a routing issue. Show IP route 150.1.6.6. .239 6.6.6. Outgoing interface list is stopped. Why is that? Yeah, star 239.666 is all right, so let me think about why would it think that it has to forward out this interface. So we've got a loop here, and it's at router 5. And I think this has to do, so router 6 is going to announce an IGMP message. Router 1 should win this election. All right, let's take, maybe this is just a order of operations issue. So let's stop PIM on router 5 on these interfaces. Interface T0, no IP PIM. Interface GI0, 145, no IP PIM. Okay, show IP M route. says stopped. Clear IPM route star. Show IPM route. Incoming null. Neighbor directly connected. No IP PIM. Where else is it running PIM? Oh, loopback probably. Yeah, router 5. It doesn't really need it there. Not for this lab. And tunnel 10, yeah. Interface T10. No IP PIM. Okay. Excuse me, and I sure hope we have volume here. Hope we've had it the whole time. Okay, so clear IP and route star. Show IPM route. Nothing. Okay. Now let's turn it back on. Interface T10, IP PIM dense. Interface GI0145, IP PIM dense. Interface GI0158, IP PIM dense. All right, we'll give it time to. Now star comma G should be coming from the tunnel. Incoming interface is null. Incoming, outgoing is 45. Yeah, see, I don't get this. This star comma G should be coming through the tunnel. Show IP M route. Okay, he's going to send it out. So I guess the star comma G, I need to really go back to that because that means where I have receivers. But star comma G for that segment should be router 1. Let's do a search. How do we determine IP PIM DR? PIM DR priority. Here's a blog, Brian's blog. The PIM DR in a sparse mode is responsible for source and receiver registration. Yeah, PIM DR. We want to see it in dense mode. Multicast PIM DR versus PIM Assert. Routing null 0. Interesting. PIM DR and the PIM Assert, what exactly they're used for. So if multiple PIM routers are attached to the same segment, DR will be elected. The same election rules as PFUs apply. In PIM SM, the DR is used to forward the PIM join from the receiver to the RP. By default, the highest IP address determines. One thing I did is that the PIM DR is also used to forward the PIM register on behalf of the source. The PIM DR purpose is to forward the PIM register on behalf of the source and join prune messages from the receiver. Not multicast traffic, just the PIM register and PIM join prune. Okay. Well, the PIM Assert is pretty straightforward. It's used again in a multicast, but this time to forward the multicast traffic. When two routers see the same multicast packets from the same source. Goes against everything with the efficiency and bandwidth. For this purpose, a PIM Assert forwarder will be elected on the network segment to avoid duplicate traffic. Okay, that makes sense. The way a router detects duplicate is that if it sees in its outbound and its OIL the same SG pair, it starts to send assert messages. Assert messages contain the metric. Once it knows it needs to elect an assert forwarder, the election goes this way. The router. Okay, so DR and assert are two different things. The PIMper is to forward the PIM register, which we're not using here. So DR really makes no difference. The PIM is to forward in a multi-at when two routers receive the same. Okay. Okay. All right. This is good. I like this. 2014, but I'm going to put it, folks, in this in the links for today, because this is great. So yeah. No wonder I'm hitting my head against the wall here. That's a meat chunk for sure, guys. PIM DR versus PIM Assert. Here I am thinking I'm typing PIM DR all day long, and it's for two different things. So the designated router, this is learning in action, folks. You want to see learning here in the stream. You're seeing it happen live in all its glory or lack thereof. So on this segment, when we do a DR election, the DR election is for receivers to, you know, at some point we have to send an announcement to the rendezvous point. So why send it from both? He's just trying to register, right? He's just trying to register. So if we want to influence who gets to send those registration messages, forward them, that's what the DR priority is. All right, that has nothing to do, though, with the paths taken for multicast traffic. So what's happening here is router 10 is sending to router 8, sending to router 5, and then router 5 has two outgoing interfaces. Why? Because I want to type this here. The star comma G is sent out to all, it is multicast to all multicast listeners on this Ethernet segment. Both router 4 and router 1 receive the star comma G, and then they forward that to all their multicast interfaces. So router 5 is going to actually have two two interfaces on which he has outgoing for star comma G, right? That makes sense. So let's just verify that. Show IP en route. We have no traffic, so we've expired that. Okay. So he has two outgoing. OILs. He has one incoming and RPFL passes just fine. And he has two OILs. But for some reason this is stopped, probably because of a prune message. Right, now why has router 4 told him to stop? Or router 1? So there's a star comma G directly connected, and outgoing is Jet 0146 and tunnel 10. Incoming, tunnel 10, outgoing Jet 0146. So in this particular case, he is an assert winner. So we're not really going to prevent, I don't think, at least the way it looks now, what should be happening is router 5 is going to flood down both interfaces. He theoretically would. And then we would have an assert winner here due to the static route. And the assert winner would be router 1. So router 4 might receive them, but he would discard them, and router 1 would flood them to the segment. Why have both of them flood? In other words, why have him send it here, and him send it here, and here? Right? So we have an assert winner is router 1. He's going to send it here and here. But for some reason, when router 1 wins, he is sending a prune message this way, I believe. Let's double check that. Let's stop our captures because they're probably huge by now. And we want to look at router. Yeah, let's stop this capture. And delete it. Okay, and then let's start a capture on router 1 and router 5. We really only need router 1. Well, let's do router 5 too, just in case. Okay, and we're going to do Jet 01 on both. Traffic capture. And this is going to be called R1, R5 group. Our P cap filter is going to be IGMP or PIM or ICMP. Who is this, by the way? CCA 48240 and CCDP. Nice. Diego. Hey, Diego. Good job. Routing 00. I like this page. Looks cool. Good stuff. Okay. So what we're going to do is we're going to kind of shut things down. We have an M route here. As far as I could tell, this is not a problem. RPF neighbor, RPF check passes. Yeah, I just don't know why this is showing as stopped. Why is this OIL stopped? Show run interface T10. It is configured there, right? Yeah, okay. So what I'm going to do is I'm going to start a new capture, which I did already. I'm going to clear IP mroute star. Interface range T10, GI0 145. No IP PIM dense. Okay. And turn it back on. Debug IP PIM. Show IP mroute. Incoming interface. So this would imply that star comma G is directly connected. All right, let's look at our PIM advertisements here. Why is that the case? We're going deep, folks. Let's make sure we understand everything that's coming in. All right, what did router 5 see? Are we still running pings? No. Okay. So let's see our hellos. This is from router 1. And it is coming. I did select router 5, right? Yes. 146.1 interface. Destination. That's just hello. Why would this be coming in on this interface, though? All right, this is router 4. Okay, 45.4. Sent a PIM hello. DR priority 1, they should both have this. Router 5 should actually win, right? DR priority 1. Okay, here we have a join from router 6. Don't know why I'm seeing this. Okay, a prune. That's a prune. We have no more traffic, right? Okay, fine and good. Membership query from router 5. Then we have a membership report for 224.10140. That's fine. Where are these pings coming from? Okay, membership group. Router 6. Okay, IGMP message. And 4 is going to join or prune. Okay, these are prunes. Yep, join prunes. Okay, that's all like maintenance. Okay, membership query. Here we go, membership report. No, not yet. Okay, membership report. 224.10.10. Okay. Hold on a second. Show run interface J0110. We got old junk in here. Yeah. Darn it. No IGMP join. No wonder we've got all kinds of stuff going on. 01. Why do I have so much trouble? Interface J0110, right? No IGMP. Oh. Okay. Do show run interface J0110. No IP IGMP join. That's what I always do. 239.0.0.1. Stuff's clogging up our captures here. And do we have any pings running anywhere? I'm seeing all sorts of pings. Maybe this is an old capture. All right, I've lost my point of reference here. I don't even know where. I don't even know what to look at in that capture anymore. So I'm going to delete this. And I'm going to delete this. I'm going to remove this on router 6. Show run interface J01 on 46. Yeah. I'm going to say no IGMP join group. IP IGMP. 239.666. Okay. So, and I'm going to put that back in a second, and I want to see how the star comma G forms. That's what's got me confused right now. How is our star comma G forming? Okay. So let's come back here, router 5. Got to break it down, make it simple here because, okay, we're going to do PIM, IGMP, PIM or IGMP or ICMP. Create. Okay, now let's turn this back on. Router 6. I have more problems with that command. Okay, boom. Now, let's look at our capture. Well, first of all, let's look at the router, right? So, in dense mode, this should get announced out all interfaces that are speaking multicast, right? So show IP mroute 239.666. There's our star comma G. Incoming interface null. Outgoing interface 4 and 5. And tunnel 10, okay? All right, so it came in. We don't know where it came in. We're about to find out. We're about to find out, folks, because PCAP don't lie. That's way too loud. All right. Membership group report, router 6. So that's interesting. That sounds like What is the Ethernet source? FA163E2790E1. So is it not changing the source address? Show IP ARP. Where's the first one? Membership group report came from this Ethernet address. FA163E2790E1. Show IP interface brief. Okay, it must just be hearing that. This is in promiscuous mode. So it is getting that from router 6. Because if I look at router 6, yeah, router 6 connection to 67.6. That is the same Ethernet address, isn't it? FA163E2790E1. Interesting. 67.6. All right, so there's a little wonkiness here, guys, because this show run interface just 0167. This is not even running PIM. Is that the same Ethernet address? No, this time it gets it from, oh, that's not it. 239666. Yeah, 90E1. Man, this is where I almost wish I could do this on a real router. Because, let me shut that interface down. Shut. Show IP interface brief. So yeah, that should be the only place. Let's stop and start again. So weird. I'm not sure how we're going to be able to. Delete. And let's capture on routers 1, 4, and 5. J01, J01, J01. Yeah. Traffic capture. R1, R4. And this will be PIM or ICMP or IGMP. Driving me nuts, guys. Okay, I'm going to take this out. No IP IGMP join group. And then we're going to put it back. And look at our capture. Okay, zip file. And where did it go? Okay, Jezzer, get rid of that. Rid of that, rid of that, rid of that, rid of that, rid of that. Download. Oh, it's just called R1, R4. Okay, R5. Router 5. IGMP. Leave group, right? We expect that. So now we have a membership group from router 6. And the Ethernet address is the same Ethernet address. Same Ethernet address. I don't get it. That makes it kind of hard, folks, to really... So even if it changes the source, I should have a different Ethernet address. I don't even know. What I could do, guys, is if we look at this, so let's take a look. We might have to build our own lab for this because this is just not working the way I expect. That Ethernet address doesn't even make any sense. That is an Ethernet address for a, let's look on router 6, for an interface that is shut down. Oh, no, it isn't. Now it's switched over here. Okay, 9001. Okay, that makes sense. But why would we be seeing that on router 5? What are my simulations? Can I see my simulations running? Yes. So as you can see here, we have an unmanaged switch. So router 6 is going to be sending these, and it's going to go out all interfaces except the one it received on. This is an unmanaged switch. So router 5 will receive that, but he should also really... Yeah, I don't know. Because does that break the multicast? Because if you look at it, it sends it to a multicast Ethernet address. So router 5 is going to receive that, but he should discard it. Don't see any entries for 22. Yeah. If I do show IP route or mroute, okay. Put this back. Receive 4224040 receive group. Cancel excluding. Well, do I have it on router 1? Okay, yeah, I have it. Forward to tunnel 0. Tunnel 10, 239.666. I bet router 4 has it. It does. It should be forwarded to router 5. Router 5 does not have it. I don't know, guys. We may have to do this on real hardware because something is not working exactly right. What I could do is I could set up a new lab. Let's do a new one. Yeah, I could set up a new lab and do direct connections. And then see what the IGMP messages look like. But with looking at it this way, I think it's just going to confuse us more, to be honest. Cancel. We'll just have to leave this up. Yeah, what should be happening is we should be getting this from router. See, we get these from router 4. But we only get announcements for 239.666 from router 6. But what should happen is the IGMP message should come here, and then it should be flooded this way. And here, and flooded this way. But I don't see them getting here for that 239.666. Membership query specific. Leave group. Interesting that he sends a query after a leave. Membership query general. Membership report group from router 6. Yeah, very strange. So I don't even have a route for that now. And he should be forwarding this. Okay, let's do a ping here. I'm not even sure how that's working. Now we have it. And this is stopped. I don't know why this is stopped. And it gets to router 4. And this says pruned. And it's going this way now. Now it's working the way it should. Yeah, now it's working the way it should. It's using this route. And this is pruned. Why wasn't it doing that before? Might be failing. Hey, I just saw your... For Johns, thank you for the chipping in here, man, for some help. Yeah, I don't know, but see, even so... Even on router 5, we should have received a star G. And we weren't even getting a star G until we started doing the ping again. And now the pings work. And they're going the way they're supposed to. It just seems a little buggy, man. I don't know. See, that has a PT before it did not. Because we have a route here, show IP mroute, or IP show run. And sure enough, that did not work before, I swear. Did not work before. What we did is we removed PIM from these interfaces, added them back, made no other changes. We did remove the IGMP request here. The join group, we removed that, put it back, remove that, put it back, and then did a ping here, and now it's working. So I don't know. What is disconcerting to me, though, more than anything else, is the packets I'm seeing for the IGMP membership reports that router 5 is receiving from. That's probably what it is, you know? Come to think of it, here I'm getting a membership report from 155.1.146.6, and guess what? That's not a directly connected interface. So no wonder he doesn't add it. But at some point, router 4 must have sent him one. Let's see. Let's look at this now. So strange. He should not be seeing IGMP messages from router 6. Let's see here. Let's delete that. Open this back up. Router 5. Let's look at these membership reports. Let's just do IGMP. And for a specific group. That's too big. No. Watershark's a little wonky on the Mac here sometimes. Okay, how do I bring this over? Okay, that's good. All right, so membership reports. Membership report, all these are coming from router 6. Which is fine. If it is indeed true that a membership report is flooded, but the source IP address is not changed. Maybe that's how that works, I don't know, but the Ethernet address should not be router 6. Yeah, so how does router 5 ever know to forward this out of those other interfaces? Membership report 146.6. Same Ethernet interface, 90E1. Unless the Ethernet frames are forwarded, but the source Ethernet address is not changed either. We may have to go to our RFC on this. Let's look at the. Let's just look at all of them. I don't know, I think I'm at the point where I'm just gonna have to kind of move on and save this PCAP and then move on to the next lab. And in each lab, just kind of take closer scrutiny of what is going on with these IGMP messages. Because something is not adding up here. Membership query general, membership query, report group. This seems to be right. For 224.0.140. Yeah. All right. We'll do that. Well, let's see how we're doing on time here. 4:20. Okay. Yeah, there were several things wrong with that lab, though. But I think we've squeezed everything we're going to be able to squeeze out of it. And we're just going to have to move on to the next lab, which let me just take a look, see what's involved. PIM Accept RP. Let's look at the requirements of this. PIM Accept RP. Enable PIM sparse mode on R5 through 10. Configure R5's loopback 0 as the rendezvous point. Yep, I may just come back to this one, guys. I need to research this one a little bit and just take a little break. We've been labbing now for going on just about 2 hours on this one. So, yeah, I think I'm going to take a little break, folks. Thank you so much for tuning in. Appreciate the feedback and the support. Feel free to follow if you're enjoying this, and you get notified whenever we're back on stream. And also, you can follow us on Twitter, Instagram, and all those goodies. Thanks so much for tuning in, guys. Happy labbing, happy learning, and we shall see you back here soon in the Land Tamer stream. Take care.